Hello everyone. Today we're going to talk about the topic image encryption using visual cryptography. We are from group 15. My teammates are Sahana, Sattar. Yeah, so let's start here. Here are some of the topics that we'll be discussing. That is visual cryptography, pixel patterns, encryption and decryption, and we'll also be seeing a demo of the prototype. So in visual cryptography, what is visual cryptography? It is a cryptographic technique which allows visual information such as pictures, text to be encrypted in such a way that the decrypted information appears as a visual image. So where did it start? Noor and Shamir in 1994 presented the first method called the secret sharing method, where an image is broken into n different shares. And even if we have n-1 shares, it is not enough to decrypt the image, to decrypt and get the original image. So similar idea was presented, and it is called the transparencies, which are used to implement one-time pad encryption. So in this one transparency is a shared random pad, and the other acts as a ciphertext. So to look at this, we'll be discussing about the tool called crypto tool when we see the demo. First, let us see what are pixel patterns. So as we can see, to encrypt black and white image, we'll need a black and white pixel. So different pixel patterns are needed for the encryption. So here are some of the 2x2 pixel patterns, that is horizontal, vertical, and diagonal. Next, we have the white pixel encryption. So to encrypt an image in white pixel, we choose a random pattern and use the same pattern for the image 2 and image 1. And when we combine, we'll get the similar pattern here. As you can see here, we have pixels, white pixels and black pixels. So this is why it is called white pixel encryption. Next, we have the black pixel encryption. Here we have only 3 different possibilities, and we use a pattern and its inverse for the black pixels. So for image 1, we choose a random pixel pattern and take the inverse of that image 1 and use it as image 2. And once we combine both, we get a black pixel that has all the pixels as black. Next, we have the concept of encryption and decryption. So here we create, from the original image, we create 2 different images, that is image 1 and image 2, where one of the image is used as a shared one-time pad and the other is used as a ciphertext. It can alternate. Any image can be used as shared one-time pad, which is shared between the sender and the receiver. And when we combine both of these, we'll get the plain text. So we can combine the images by printing them out on plastic sheets and overlay them in a perfect alignment to finally get the decrypted text or the plain image. Now I'll hand over this to Sahana. She'll take over from here and show us the demo.
Thank you, Vandana. So here for the demo, we will be using the tool called Crypto Tool. So this is an open source provided by the team, and we can have a crypto tool downloaded in our local system, and we can do demos on how an image can be split into 2 images, other ciphertext. So here if we go to the download options, we will see the exe file to download directly the exe file, or we can download a zip file and we can run the application. I have downloaded the zip file and I'm running the application. So this is the image I have considered. This is the original image, which I will be splitting into 2 ciphertext. And once we club the ciphertext, we will see what is the outcome. So this is the tool I will be using. So in this tool, let me start from the beginning. So we have main functions, we have templates and the YouTube link on how to use this particular tool. And in the template, we already have an existing visual cryptography tool. So for the demo, I will be using the default template. So when we use this template, by default, we will see a plain text which is getting visually encrypted. And let me show you how this is happening. Let me give my name here, Sahana, and if I play it, you can see here the image is split into two ciphertext image, that is image 1 and image 2. When we overlay this text, we will see a actual image. So let's go here, and if you see here, for the demo purpose, I'll try to overlay these two images. You can see the as soon as like I overlay properly, you will see the original image. So this is for the text. Let me do it for the image. Let me close here. For image, I can remove this plain text. I can introduce this file input where I'll give my image file as an input. So I have selected it. So let me put it here, and then in the settings, there are two options to upload a file. So I'll be opening a file, and just a minute. In the downloads, um, yeah, sorry, in the document, downloads, and yes, yeah. So I'll choose the same image. So the file is uploaded, and when I run this, you can see that two ciphertext is created. Two ciphertext, the picture outputs are created, and when we overlay these two pictures, we will see the actual output. So these are the two images which are created. I'm just trying to overlay and show it how they can decrypt. So you can see when I overlay one cipher text image with another cipher text image, we will see the exact what we call the original image which got encrypted. So here, as Vandana said, we can share this one of the image to the receiver, like end users, and we can keep it as a secret cipher text. So this is all about the demo. So thank you all.